Hello everyone, welcome to my channel. Today we're going to be studying about this concept of vectors. So the question over here reads, OAB is a triangle. The point P lies on AB such that OPQ is a straight line. The fact that they've given you this concept where it says it's a straight line probably means that we should be using something that is related to collinear points. Collinear points. Having said this, the next part of the question says, the point M lies on OB such that OM ratio MP is 2:3. So I know that this side over here is 2 ratios, and similarly M to B represents 3 ratios. Now this question over here has given us the vector for OA. Let's label this out. So we are given with OA over here. And this point over here is 3A. Let's also mention the direction. In a very similar way, we have OB as well. OB. This is given to us as 5B. In a similar instance, you can see that they've given us BQ. But the problem is that there is not even a single line that connects B to Q. So what? In these kind of questions, I would recommend that with a pencil, you should draw this line. Label out the direction as well. So I know that this has to be 6A minus 3B. Now, the first part of the question says, find in terms of A and B, simplifying your answer where possible, AB, the vector AB. Now, there are two ways of solving this. Either you can use the vector subtraction method, that is OB minus OA, or you can consider this as a path. That means if I want to go from point A to point B, I should be moving from A to O, and then perhaps moving from O to B. If that is the case, then again, we get the same answer as well. Let me just plug in the values over here. That's going to be 5B minus 3A, or otherwise you could have said AB is A to O, and similarly O to B. That also gives us the same answer as well, because we get minus 3A plus 5B. So whether you use vector subtraction or you start forming a path, it's basically the same thing. In a similar way, the next part of the question says, find OQ. To figure out OQ, let me just clean up this mess. To find OQ, I know that I have to start my journey from this point, and I have to, as an end over here at Q point. So in order to go from O to Q, I can perhaps move from O to B, because that's the line that is already made. In a similar way, B to Q. So if that is the case, let's write down the path over here. That's going to be O to B plus B to Q. O to B is given to us as 5B. In a similar way, B to Q is also given to us as 6A minus 3B. This would end up giving us the answer as 6A plus 2B. This over here represents my OQ. The next part of the question requires you to figure out MP. I want you to pause this video for a minute, and I want you to try this out yourself. Let me just bring this right next to this. All right. All right. Now the question says to find MP. I'm pretty sure most of you might feel a little stuck over here, but let's see. So in order to go from point M to point P, there's not too many ways for me to reach, as in from this point to this point. So let's just first, start writing down the direction. So I know that in order to go from point M to P, I can perhaps move from M to O. In a similar way, then I can go on to O to P. The problem over here is that I'm not certain about the vector value for OP. This is where the problem is. Now let's try to label out whatever we have for the remaining parts. Since the question has already given us the value for OM, or I should say OB, which is 5P, and they've given us the ratio over here as well, that is OM ratio MB. That means this side over here is 2 ratios, and similarly this side over here is 3 ratios. So we have a total of 5 ratios that represents 5P. So 5 ratios, they represent 5B. That means 2 ratios would represent 2B, three ratios will represent 3b. That means I'm very certain about the value for OM. So if I just kind of erase this, I can say that O to M, which is two ratios, is actually 2b. In a similar way, M to B, which is three ratios, that's going to be 3b, which again totals up to 5b, which is OB. So I'm very certain that if I were to plug in this value of MO, since I'm moving in the opposite direction, that has to be minus 2b plus OP. But this is where the problem is. I'm not certain about the value of OP. So I'll just take a pause over here and I'll first figure out the value of OP. Now, to figure out value of OP, I can see that OP actually lies on the same line that we have for OQ. So if I were to write this down as a vector, I can say OP is equal to K times OP. What is K? K is a constant value that I'm just taking. K times OQ, yeah. So that's going to be OQ. Now let's try to plug in the value of OQ that we figured out in this second part. This came out as 6A plus 2B. So I have OP in terms of K. That doesn't really help us because we need OP we need a value, for OP vector. If that is the case, in how many ways can I reach from O point to P point? So whenever you come across these kind of questions, you need to realize that when you get stuck at such a point, you need to start figuring out in how many ways can we express OP. So one way, of course, is by saying that OP is, again, a scalar multiple of OQ, which is, again, the same concept as K times OQ or any constant times OQ. Another way to go from O point to P point can be written down as OA plus AP. I'm sure some of you might have questions. Why can't we go in this direction? We can. So you could say that O to B plus B to Q, that doesn't really changes anything. You still end up getting the same expression, or I should say the answer, which will be the same. Anyway, since I'm taking OP as OA plus AB, so I can say that OA is given to us as 3A. But again, now I'm stuck at this point, that is AP. But I can definitely see that AP is a straight line as well. And whenever we talk about a straight line, we can always express that as a scalar multiple. That means I can write down AP as maybe some other constant. So I shouldn't take K over here because I've already taken K for OQ. Now, in this case, I can say that's maybe U or mu times, mu again is a constant, so don't get confused. Mu times AB. Can I say the value for AB is something I already know, which is something that we figured out in the first part? That is 5B minus 3A. Let's just plug this over here as well. So I can say that's going to be plus this value. This over here represents OP. And this also represents OP. Can I say they're basically both the same thing? That means they're both equal to one another. So I can write this down as K and then 6A plus 2B is equal to, we have 3A plus this mu or constant 5B minus 3A. At this point in time, you can actually start comparing the A values and the B values because we know they're corresponding values. So can I say from the left side, I can say that's going to be just K times 6A. So K and then 6A. Similarly, if I compare the A, I would say vector on the right side, that has to be 3A and then mu times minus 3A. So you could say that's going to be 3A plus mu or minus mu 3A. I'm just multiplying this. Don't get confused. Now I can just cancel out the A because I know it's common in all three of them. That means I should end up getting 6K equals to 3 minus 3 mu. I can express K as perhaps 3 minus 3 mu over 6. You can simplify this as well. You could take 3 common out, simplify this fraction. I don't need to at this point in time. I'll start off with comparing now my b value. So again, when I multiply this, that's going to be k times 2b is equal to, on this side, we'll just be having mu times 5b. Why is that? Because on the right side, there's only one value which contains b. So now let's again cancel out the b's. That means I end up getting 2k is equal to 5 and then mu. Is there any chance you can probably plug in k value, which you figured out? Can you substitute this value? Of course you can. That means this will be 3 minus 3, and then we will be having this constant over 6 is equal to 5 mu. Simplify the fraction. That's going to be just 3. And then if you simplify that as well, that's going to be 1 minus mu is equal to 5 mu. If I were to move this on the other side, that's going to be 6 mu is equal to 1. That means mu, or this constant over here, represents 1 over 6. Now that I have this constant, I can easily figure out the value for OP. Now, some of you might have some questions. Why did you not figure out value for K? I can, it's just not required, because I know that OP is also expressed. This is my OP that is also expressed in mu. So as long as I have the value of mu, and if I plug in my value of mu, I should end up getting the answer for OP. If I did, that's going to give me, so let's just plug this value of mu as 1 over 6. I'm going to expand my fraction over here. 3a plus 5b over 6 minus, when I multiply this, that's going to be minus 1 over 2a. If you were to solve this, 3a minus 1 over 2a, this will end up giving you 5 over 2a plus 5 over 6b. This is my value for OP. But the question didn't ask us for OB. The question was asking us to figure out MP. But if you start thinking about it, we did partially figure out MP. So I did have, as in I did calculate MP in terms of B. I just had to plug in this OP. Now that we have this value for this vector, we can easily plug this in. That means this will become minus 2B plus 5 over 2A plus 5 over 2a plus 5 over 6b. If you were to solve this, take the LCM of minus 2 and then 5 over 6, you'll end up getting the answer as 5 over 2a minus 7 over 6b. This over here is my final answer, which represents the value for MP. I hope this question did make sense. I know it's a little cumbersome, but hopefully, if you try this again, you'll be able to get it. Thank you so much. Till then, adios.